Good morning, everybody.
Morning.
Welcome. Thank you for attending. My name is Bryce. I'm the Elonics sales manager based in KZN. Nice to meet you all. Today we are going to be just waiting maybe another 5 or so minutes just to allow a few latecomers to the meeting. If you don't mind just muting yourselves if you've got other work to do, and that we'll probably start in the next 5 or so minutes. Your host today will be Devin Govender. He is our technical director and head automation technician / engineer for Elonics. Some of you may know him, some may not. But he'll be in charge and taking care of you this morning. If you have any questions, you're welcome to unmute yourselves and ask as they come up, or you can send us a direct message and we'll try and answer you in due course. This training is being recorded this morning, so that if you guys do have to leave or if you can't make it for the full session, we will be uploading it to our YouTube channel, so you guys can catch up when you have some free time. But yeah, we'll be in touch. Thank you for coming, and I hope you guys enjoy it.
I guess we'll just give it another 2 minutes and then we'll start. Good morning, guys.
Morning, Devin.
Sorry for rescheduling last week. Obviously, unfortunate circumstances forced our hand there. But we're here today. And hopefully you guys are happy with the training and start using LSPLCs. Okay, so firstly, we're going to start with, I'm sure more people will join as we carry on, but we are going to start anyway. So firstly, we're going to start with our product lineup, little slideshow just to show you what PLCs we have, and then we can start the training from there. Can you guys see that?
Yep.
Yes.
Okay, so LS, close that. So our product lineup includes our XGR top of the range PLC, which is our redundant PLC. About that. Then we got the XGR high performance, which is also a rack. And then we have our XGT compact brick type PLCs, which also comes in its own range, which we will go through. And we have our HMI touch panels. The XGR PLC, as you can see, is our top of the range high performance, 131,000 IO, full redundancy type PLC with various communication networks, Ethernet, Profibus, DeviceNet, 232, 485, etc. And supports ring configuration to prevent a line disconnection error. Also supports IEC standard language programming. And the nice part is the XG5000 supports the entire range of PLCs. So you don't need a piece of software for the XGR, for example, and another piece of software for the brick. It'll be the same software for the entire range. Then we have our XGK, XGI, high performance PLC. This is our number one selling rack with a range of CPUs. As you can see, you got the CPU-U, CPU-A, CPU-S, CPU-E. Obviously, each CPU has its own strengths when it comes to I/O. Once again, variety of communication networks, built-in PID. Then we got our XGB, XTC bricks, obviously our number one sellers because of its price point and convenience of use. So we also got fast processing, 83 nanoseconds per step, maths operation, 7-state expansion points on the XCC, and obviously designed for small to medium-sized systems. Also come built-in 16-loop PID control, built-in 232 and 485 on the SU and the U. On our E, which is the economy PLC, it has 232 and 485, but you can use either or. They also come built-in high-speed counters, and if you get the transistor version of the PLC, you can use a position. It comes built-in high-speed positioning as well. First, we have the modular type, which is our little PLC, a little cigarette box type PLC. Then we have our major bricks, up to 384-point I/O, starting with the SU and the E. Our HMIs, actually this needs to be updated. We have our new range of HMIs, which is actually not on the slide, which are EXP and our IXP2 HMIs. And then we have smart IOs expansions, extendable IOs that can all be used with our range of PLCs. Okay, so that's just a simple little lineup of the PLCs that we have. I'm just going to stop sharing this screen. And then I'm going to go into XG5000. Okay, so this is XG5000. I've opened the program already. Generally, what happens when you first install XG5000, you're going to have all these windows pinned. So what I generally do is I unpin them, let them sit at the bottom so that you have more space to program. So I just unpin them. I'm sure you guys notice if you guys have installed XG5000 already, then you would have actually spotted that all your operational bars are open. So in that case, I just minimize them so I got a nice clean screen to start with and make things a bit easier to program. So firstly, obviously we want to create a new project. You click on project, new project, and now it lists your project name. Where do you want to save your project to? What's your CPU series, your CPU type? So as you can see here, you got your XGK that we looked at, the XGB, and as you can see, there's an XGB and there's an XGB IEC. Now, the XGB without the IEC is basically your non-standard, is the non-IEC programming language, where you actually create a function block and then reference it after. Now, we don't bring those PLCs in. We just bring the standard IEC PLCs in, which is much simpler to program and much better because you don't have to create a function block and then reference after. Basically, the function block that you put into your program is the same one that you reference. So with XGB, we will work with XGB PLC today, but as you can see, we've got the XGI, XGR, XGS, and the whole range. So right now, we're going to work with XGB IEC PLC. And the CPU type, if you look at unfortunately, yeah, you guys are not in front of it, but the PLCs we got the E range when it comes to the XGBs, which is the economy PLC. That can only be programmed via 232 loader port, which is up here, and can only expand on the top. You cannot do side expansions on it. It's a very basic PLC for simple applications. The H we don't bring in because it's unnecessary, not necessary due to us having the S and the U PLC. So we have the E and the S, which is also a very popular PLC because it supports side expansions and top mount expansions as well. And it's at a very reasonable price. And then we got the UPLC, which was the one we will look at today because it has the most features. And it has side expansions as well as built-in Ethernet. So the reason I'll do this is because we can look at the Ethernet settings as well on the PLC. So we're going to select the XECU. We can give our project a name. So let's call it December training. And as you can see, you can actually decide where you want to save your project by clicking on there and selecting your desired directory. If you've got a customer that you're doing it for, then you save it in the customer directory as an example. So as you can see, it's right now it's saving it actually 5,000 under projects December training as a default. So whatever project name you give it, it automatically creates the folder. Default is XGI programming because that's what it is. And then you can give your programmer name as well. So let's just call it training as well. And then you have your programming language. So we support ladder, a sequential functional chart, structured text, and instruction language. So this introductory training session is going to be on ladder programming. Obviously, it's the most commonly used PLC programming language. Okay, so you can give your project a description if you want to as well. It's purely up to you. Hit OK. Now what this does, as you can see, it brings up your programming window. Now, as you can see, it's a little short. You still have a whole lot of space to play with. So what I do is I increase my columns. Just put this little button in here, a little shortcut. You can increase your columns. So now you have a much larger area to program with. It's really up to you. You can shorten it, lengthen it. Sometimes it's based on resolutions of screens. So some of you might not be able to get as much columns as others due to resolution of screen, or you can get, or some might even get more with a high resolution screen. If you have any questions going along, please let me know. If anything's unclear, then I'll let you guys know. Okay, so that's your programming window. This is where you're going to put your coils, your contacts, your function blocks, your timers, etc. But firstly, let's see what our PLC has to offer. So under our project window, let me pin this for now. So what this shows you is what this PLC has. So it tells you here it's an XECU PLC, it's offline. It has built-in CNET, which is your serial connections. and built-in Ethernet, which is your Ethernet connections. So let's start at the top. So if I double click on CNET, it tells you I got RS-232 on channel 1, I got RS-485 on channel 2, your baud rate for each one, and then what connection do you want? So if you use P2P,
Governor.
right?
Sorry, I'm trying to follow you on the program. I opened it up on my computer as well, but for some reason it doesn't want to save it because it says there characters that it can't contain to save it. But
Okay,
I can't.
did you put in any different letters, or did you just put what name did you give it?
No, I just said project name December and then program name training 1. But
okay, the program name cannot have a space.
Yes, it does.
You can put an underscore.
Okay, let me quickly. Thank you. Problem solved.
There you go. Okay, so the operation modes, XGT server is basically your default. That allows you to connect to an LS HMI. P2P supports Modbus, which we'll go through a little later for communication settings, and it obviously supports full Modbus settings as well. Okay, so we're just going to leave it as XGT server for now. Say okay. Okay, then if we double click on Ethernet, okay, hold on, let me just change my colors on my, so it makes things a bit easier for you guys. Give me 1 second. It's not the best theme. Okay, that's much better. Okay, so under Ethernet settings, we got a station number. Station number is related to when you have multiple PLCs connected onto the same network. So obviously, if you want each PLC to talk to each other, each one's going to need its own station number. Then you can set your IP address here to whatever you want it to be. And as with the CNET, you got the choice of XGT server and Modbus as well. So I say, okay, we can leave that as default for now. Then you got your system variables. As you can see, there's nothing in there at the moment. That's when you actually add variables into your system. And then you got your global variables. Your global variables are variables that are used if you've got multiple programs in a single project. So a global variable allows each program in the project, we will do that just now though, to access a global variable. Whereas a local variable is for that particular program only. Okay. Then we have basic parameters. So basic parameters tells you your scan time, basically how long it takes for your PLC to scan your program from top to bottom. And then you have your retain area setup. So retain area is areas that you want to, values that you want to save after power down. So if you power up, if you got a value in a certain register, let's say, for example, we say from marker word 0 to marker word 10, all values within those addresses will remain after power down. You power back up, you got a value of 10 in there, for example, the value of 10 will remain in there. But there are other ways of doing retains. But that means if you do it this way, you basically have to structure your program to make sure that your retains stay within that area. Then you have your IO parameters. So IO parameters are important. The fact that this is where you add your expansions in, where you add your different IOs in, and where you tell it what PLC you are actually using. So the way it works is you have your base PLC, which is slot 0. You have your, on XCCU, for example, we got your main, which is your main PLC. We can tell it that it's a, let's say we're using a DR28U PLC. If you double click on there, then it tells you here you have 16 inputs, 12 outputs. So it adds this in. This is your actual brick PLC that you've purchased from us. And that's your slot 0. So main brick PLC is slot 0. Anything you add after it is an extra slot. Yeah. But being the XCCU PLC, the XCCU PLC has built-in options as well, where you can actually order with either analog or you can order with positioning. So what that means is that that slot becomes dedicated to those modules. So even though you order one without it, slot 1 is always dedicated to that, but only on the XCCU PLC. So as you can see, if you were to click on slot 1, it only gives you 2 options: the analog input output option or the positioning option. So we're saying, okay, ignore slot 1. We haven't ordered that version, but we want to add more digital inputs into the PLC. So let's say we want to get another 16 inputs in. So we can click on slot 2 and add 16 channels in. So as you can see here now that we're in slot 2, so it puts in 0.2.0. It gives you the actual address name of the input. And I'll show you how that's relevant to the program, why that's important to the program just now. And now let's also add in an output module, say 16 channel relay output. So it does give you the description there, so you know what it is. And you have the choice of transistors as well. And then let's add in an analog input module, a 4-channel analog input module. And then we'll add in a 4-channel voltage. So you get a DV, which is a voltage output, and you get DC, which is a current output. So let's just say DV for now. So what we have in our PLC is we have our main brick PLC, which has 16 inputs and 12 outputs. Then we've added in another 16-channel digital input card, 16-channel relay output card, 4-channel analog input, and 4-channel voltage output card. Now, very importantly, as you can see, we can go up to 11 expansions. If you need to, depends on the size of your project, obviously. So very importantly, what we need to do is click apply. So what this does is it asks if you want to register your variables. Say yes. So this gives you, so this mainly relates to the analogs, because the analogs have dedicated variables to read and write to. I'll show you how these are used in the program once we add them in. So say OK. So that registers your I/O parameters. If you want to view, if you want to change the settings of your analog, you can still, within your I/O parameter, double click on that. And it tells you, okay, my analog input, I want to enable it for channel 0. I want it to be 4020 milliamp input. And this gives you your range. So this is your raw data range. So basically, if you are reading 4 milliamps, you're going to read 0. If you're reading 20 milliamps, you're going to read 4,000. If you're 12 milliamps, you're going to read 2,000. So that's the raw value that you are going to read. And then within your PLC, you can actually scale that accordingly. So you have a choice of 0 to 4,000, minus 2,000 to 2,000, 400 to 2,000, and 0 to 1,000%. And let's enable channel 2 as well. Leave that as 0 to 10 volts. And this will be the same. So 0 volts is 0, 10 volts is 4,000. Okay. Then you also have processing, average processing. So let's say your analog jumping around a bit. You can actually enable the average processing and set it to counter average or time average to basically create a sample time if required. So once you're happy with that, you say OK. Let's set our voltage as well. Double click on there. Enable 0 to 10 volts. It won't change because as I said, it's a voltage output only card. And this is your output. So if you had to write 5 volts into your output, it will give out a raw value of 2000. And that 2000 will equate to 5 volts. And if you write 4000 into the value, it'll equate to 10 volts. So that's if you're using it to control the speed of a VSD, for example. So you say, OK, let's enable 2 channels here. OK, and apply once again, because you made changes to it. And as you can see, it didn't ask you to register because it's already registered. You just applied the setting changes that you made to your analog inputs. Okay. Now this PLC also has internal parameters. So it's got a high-speed counter, which obviously we use for encoders or high-speed processing with proxies. Basically, any high-speed input that requires to be counted very, very fast. So I will go through that once we do the basics initially. Then we got a 16-channel PID loop for controlling pressure, controlling speed, etc. And then we have a data log as well. It's only on an XCCU PLC. Okay, so let's get back to our project window. So as I mentioned earlier, your PLC brick, your main PLC is base 0 and slot 0. So let me just have a look at something. So the way that works is, so let's put in a contact. As you can see here, you got normally open, normally closed, a rising edge, falling edge, and little shortcuts as well. So what makes it easier is so you don't have to always click on there. You know, if you press F3, you're going to get a normally open contact. So let's click on here. So what this does now, it opens up your variable window. So right now it's listing all your global variables that are listed here. And these are all your analog global variables that automatically created when you added them into your IO parameters. So we're just going to create a local variable for now. As you can see, there's nothing in the local variables because nothing has been created. So initially, we can give the variable a name. I've created a normally open contact, and we want to give it a name. So let's just say we'll call it the start button. Once again, if you look at the names, the PLC does not like, the program does not like spaces. It accepts underscore or no space at all. So to make programming easier to follow a little easier, you can say, put an underscore in, you can say start button. Say OK. So it pops out now. Okay, because it's a contact, it's going to be a Boolean. A Boolean is on or off. It's not going to give you a choice of anything else. A variable, it's a variable, any variable constant. Obviously, it's not going to be a constant because it's going to be a contact that's going to be changing. And a variable external is when you set it to a global variable. But right now, we're going to work with a local variable just for the single program. Okay, so when it comes to addressing the PLC, so on our PLC, obviously we can wire up our inputs from input 0 all the way up to input 15, which gives you 16 inputs. So the way the addressing works is, so you need to tell it, my start button is on input 0. So how do you address it to input 0? So as an input is I, as we know, but I've also said that the PLC, first input on the PLC is base 0, slot 0. So the way it works is it's base 0 dot slot 0 dot input 0. So your first base is base input on your base slot input address. If you want to put on input 1, it'll be base 0, slot 0, input 1. So that address for the base, So the base PLC will be from 0.0.10 all the way up to 0.0.15. So we're going to leave it at 0.0.0 now as an input. You can give it, we don't need initial value because you're reading an input, and then you can give it a description as well. But as I've given my variable a name, I technically don't need to have a description because I know it's my start button. But let's give it as well. Say OK. So now what this has done, it's given you your normally open contact. It's giving you the name, but also we'd like to view what is the address. So what this nice little function, nice little feature of the PLC program, FG5000, it gives you a little all button. So what this does is, in green, that's my description, this is my variable name, and this is my address. So you can view all items related to that contact. Okay, so now we've got a start button. Now we want to give it a coil, an output. So you can see here, coil, F9, go there. Click anyway, it's going to load it on anyway, and we can say motor start. Say OK. So now obviously this is going to be an output, but once again, it will be Boolean because it's an on-off. It's going to start or stop. Now we're going to give it an output address. So outputs, very similar to inputs, except that it's going to be a queue. Q is for outputs. Let's say we obviously want to use Q0 as well. Output, the first output of the PLC. So one thing, it'll be base 0, slot 0, output 0. And we can call it motor 1. So let me unpin this so we can have a full view. So as you can see, you got your start button. If you press it, if your start button comes on, your output's going to come on. Is everybody clear? I hope.
Oh, good.
But now we also have, okay, great. Okay, so let's create a little latching circuit as well. So let's say we want to, so you put another contact in there, you see that your motor start, your variable that you've created are available for selection. So you can double click on motor start. Let's join a line. You can use a line there using F6. Click on there. So what this means, if your start button comes in, if it's a push button, for example, it'll pulse, it'll start and it'll latch. But obviously you need to break a latch. So let's say stop button. Press enter, and I'll show you here. So I 0.0.1. So this shows that input 0 is start button, input 1 is your stop, and output 0 is your motor start. So when you press start, it'll latch, and you press stop, it'll unlatch. So that's a little simple little latching circuit. Now, let's say I'm writing my program. Okay, I haven't put a comment for this program, so I want to add in a line. Very simply, you can click on there, on L1, and I actually use the shortcut to add a line. So the shortcut to add a line is Control L. So that puts in another line in there, creates another little space. So I want to put a comment to say what this function does, because obviously writing a PLC program without comments and coming back to it later makes things very difficult to follow. So comments are actually very important when it comes to PLC programming. So if you had to double click on your line, select comment, say OK, and it gives you your own comment. So we can say this is our main motor start control. So this can, this can be excuse me. So this can be anything. Doesn't need, can be any character. It doesn't need to have underscores. It's purely a comment. It's text as it is. Say okay. So that tells you what that function is. So very importantly, comments in a PLC program, and also if you write the program and somebody else needs to fault find for you, it's much easier when there are comments in the program, much easier to follow. Are there any questions?
Hi, Governor. Can we just go again over the parallel contact and that normally stop that you, or that stop that you added into the line?
Yes. What do you need to know?
Just explain again how you added them.
Okay, basically using my same tools at the top here. I just clicked on the normally close contact and I clicked in the spot that I want to add it in. So let's create another one that's called e-stop. Emergency stop, press enter, and you give it the next available address that you have on your PLC. Understand?
Yeah, for some reason it throws it to the end of the line.
Oh, that's only, no, it'll throw it to the end of the line if you're using a coil.
Because now it threw my stop button directly to the end of the line and it took away the coil.
Okay, no, I'm not sure why it's doing that. Haven't had that issue before. Because the contact's always obviously before a coil. A coil automatically goes to the end, but not. So you have to, you just need to click where you want it to go, and it should actually put it in there.
Stop button.
I'm not sure why it's jumping to the end. We can have a look at that a bit later.
Okay, now I got it. And then the parallel one, is that just
And
also on the block underneath?
Yeah, I just put it on a spare block underneath. I'll put another normally open contact in there, and then I just drew the line in using the F6 tool. So you got a vertical line, yeah.
Oh, okay.
Yeah.
So I first chose the contact.
So that just closes the circuit, yeah. Okay.
Okay.
Okay, perfect.
Thank you.
You're welcome. Okay. So obviously remember this, guys, that this is an introductory course, so it'll be the basic settings and the basic functions of the PLC. And we are working on a more advanced course in the coming time. Okay, so obviously our PLC has timers as well. So let's say once our motor starts, after 10 seconds, we want our second motor to start. So let's put in another normally open contact block here. And we can say motor start again. And then timers are in your function blocks. So we click on F10, which is our function and function blocks. You can click on there. And as you can see, it lists every function that this PLC supports. So you got angle conversions, array conversions, bitables, bit operations, bit shiftings. There's a whole lot. Obviously, we're not going to go through every single one. What we want to do now is we actually want to do a timer. So you can scroll down to timers, and we have our list of timers. We got a timer block itself, timer with flicker, unsigned integer, off timers, but we'll just work with a basic on timer at the moment for the TON, which is known as TON, timer on, and you can say OK. Before I click OK, here's a nice little feature. If you had to click help, pick a function, for example, there's timer on here, click help. It'll actually take you to the help for the timer. I'm not sure if you guys can see that. So if you had to click help, it'll take you to the PDF help, of that function block itself. So it makes things much easier to understand how it works. It gives you a little description of what it does, how it works, and even a little program of what it does, which is very, very handy. Okay, so we can say, okay, you can give it an instance name. You can say motor 2 timer. You don't need to give it an address as it's a function. Say okay. And as you can see, so it's created a little timer. And as you can see, we've got a red line here. So what that means is that you have an incomplete function in that line, meaning that the PLC will go into error, or your program won't even load into the PLC because it's in error. So what's missing is our PT, which is your process time. So it means how long do you want your timer to run for, which is something that you need to put in. And the way that is done, if you double click on the spare block that's next to it, tells you what timer do I want. Okay, so timers are done in this particular way. If you press T for timer, hash, and then 10. Now, if you want 10 seconds, 10 minutes, 10 milliseconds, that's where the mnemonic comes in. So S will be for seconds, MS for milliseconds, M for minutes, H for hours. So we want 10 seconds, so we can put an S in there. If you want 10 minutes, you put 10M, etc. 10 hours, 10H. So ET is your elapsed time. As your timer counts, it'll actually show you how much time is actually being used on your timer. Q is your output. As your variable name shows Q as well, the same with your timer. So when your motor starts, 10 seconds later, your output comes on. So let's tell it that we want motor 2 to start. So let's say F9 again. You can click on there, another coil. And we can say motor 2 start. Press enter, address Q 0.0. Let me just show you this as an example. If I say Q 0.0.0, that is a used address already. If I press enter, it tells me that 0.0 is being utilized in the program already. So you can't use that output again. So we change that to 1. Okay, so when our first motor starts, 10 seconds later, our second motor starts. Okay, so let's add a comment here as well. Let's say motor 2 delayed start. Okay, so now we want to test our program. It's a little program. We want to see without our PLC, we don't have a PLC connected to the XG5000 software. We don't want to download anything as yet. We just want to make sure that our our program is healthy and that the function actually works. So you can actually, there's a little start-stop simulator button in here. Excuse me. So if you click your start-stop simulator, what this does is it builds your program and simulates exactly the same window as you would write to physical PLC. So say okay. Writing completed. And now your PLC is in run mode. As you can see here, you got a little run button, stop, and it is in monitor mode. So as you can see, these two are normally closed. Your stop button and your emergency stop are normally closed. So it shows blue that those contacts are closed. Now the PLC is in run mode. And at the bottom here, you got your green bar to say the PLC is in run and it's in simulator and everything's okay. Now, if I had to double click my start, technically, it should start. But as you can see, I'm trying to force it on, but it's not. The reason being is because this is allocated to a physical input it is looking for the input from the PLC. Double click, nothing happens. So the way that we want to test it is we need to be able to tell the PLC, okay, I want to force a digital input to come on, a digital input that is allocated. So what we do there, we go online, we say forced IO, and we want to enable the force input, say apply, and OK. So now if we had to double click on there, you can go to forced IO, say enable and true. It switches the input on. And let's switch it off. So as you can see, it still stays latched because that's our latching circuit. Motor start came on. The timer started for 10 seconds, and 10 seconds later, motor 2 started. And as you can see, on your function block, this is a new function that they added with the new release of XG5000, is now it tells you that in is high, and now Q is high. Now to stop it, let's create our stop button, force IO, enable. Okay, it unlatches it, and you can see now your input is gone low there as well as your output, and we've unlatched the circuit. Very, very simple. If you want to stop your simulator, you're happy with your program for now, you can stop your simulator just by clicking on there. But let's just say before we stop our simulator, we realize, okay, you know what, our emergency stop, we don't want it to be at input 2. We want to edit it while we're online. Now we have this PLC, even within simulator, and even if you connect it physically to a PLC, you can actually do online editing. So I will show you online editing. Obviously, we don't have a physical PLC in front of me at the moment. We will do online editing by the simulator, which is exactly the same thing anyway. So you have a little icon here that says start online editing. Click on there. So you can see your little bar, the bar on the side here now changed to blue. That's to show you that you are in online editing mode. So we want to change our emergency stop to another address. So you can say eStop, go to edit variable, and we want to make it input 10. Say OK, and immediately the entire screen changes blue to show you that you have made an edit. Say OK. Now the edit's been made, but it hasn't been written to the PLC as yet. Now to write it to the PLC, you can click down here, write modify program. Writes it to the PLC, modify program successfully written to PLC. OK. And then obviously it's still in online editing mode. You want to come out of it in online editing. Yes, and now you're back to your main program. Now you're back into monitoring your program as you would on the PLC itself. So remember, although I'm doing this in the simulator, the same thing can be done when you connect it to your PLC. You're monitoring a live PLC on your plant, but your customer obviously doesn't want to stop his plant and you need to make a small change. You can do that. So to stop a simulator, click on there, and then you're back to your programming. Any questions so far? That's good. Okay, so the program is quite versatile. Obviously, there's many lines. Sorry, go ahead.
Yeah, so this timer, this is the input function, right?
Yes.
So when the input bit in this motor start is on, this timer will start.
Yes.
So this timer function we can use as an output also.
Yes, basically it does. As you can see here, after 10 seconds, it switches the next output on.
Okay, okay. So timer
Yeah,
can
so it's an
only
on timer. It's a delay. It's a delay on timer.
delay on timer. Okay, okay,
Yeah.
okay, okay.
Then you have. I'm actually going to go through the other timers now as well, and the next timer will be your delay off timer. So I'm just going to put it in open here. TOF is your delay off timer. So obviously, the three most common timers we use is your delay on timer, your delay off timer, and the difference between the on timer and the delay off timer is that the on timer, after a certain period of time, switches the output on. An off timer, after a certain period of time, the output stays on all the time. Let's actually change this one. You can double click on there. Let's change it to. So what this does is when motor start, motor 1 comes on, Q 0.0.0, motor 2 immediately comes on. When motor 1 goes off, motor start 0.0.0 goes off, then after 10 seconds, then motor 2 start goes off. So that's a delay off timer. Then the other common timer that we use is a pulse timer. So I'm just pressing F10, obviously, to bring up the function block window quite easily. Type in TP for your pulse timer. So TP is a pulse timer. So what a pulse timer does is all it requires is a pulse. I'm just copying and pasting this here. So all it requires is a pulse to start it. So it doesn't require an always on contact. It can require a rising edge and an input that goes from off to on or from on to off. So all it requires is a pulse to start it. And once it gets a pulse, the output stays on for that duration of time only. So if you got a pulse if you got an input that comes from off to on, it'll switch the output on for, let's say you got 20 seconds. It'll keep the output on for 20 seconds and then switch off after 20 seconds. Even if your input stays on your pulse timer, even if this input stays on, it'll only stay on for its duration of time. Okay. Now, so we've done how to edit variables, how to do online editing, how to download to your PLC. Oh, sorry, we actually haven't done how to download to your PLC because we've done just the simulation. So to download to your PLC, we have the online menu. We can go to connection settings. So every PLC that we have has a USB, except our XCCU, which is serial only. So if you had to use the XCCE, it'll be an RS-232 connection to download. You can click on settings and you can tell it which port number. Obviously, I don't have a serial connection at the moment, so it'll tell you which port number you want to use, and that's the default baud rate. For USB, it's obviously not much settings for it. It's already built in, automatically install the drivers when you install XG5000. And then if you had to use Ethernet, you'll punch in the IP address of the PLC, or if you don't know what that is, it'll scan and it'll pick up the PLC. So once you select your correct communication method to download to the PLC, you can say connect, it'll connect. Then you go back to online and write to PLC. Okay, so I'm just gonna create a little error here. So as you can see, it's got the red line. So I'm gonna say view. Now we're gonna check your program before you even write to your PLC. You can click on view, say check program. It tells you what you want to check. Say okay. So I've got this, let me pin this in here, check program. Can bring it up. So it tells me that I have one error. Everything else is fine, but I have one error. So you go through your check window, you see error L02, a device or variable is not entered. So now, what if you have a huge program and you don't want to go through every single thing to try and find it? What's nice about this, wherever you see your error list in here, if you double click on it, the PLC XG5000 takes you to where your error is. So if I had to put a timer in there, T hash 20 seconds, error goes away. Then once again, you can go view, check program, no errors found. Another feature you have is your search function within the program. So if you had to press Control F is search for a variable only. So if you know the address of, not the address name, if you know the actual physical address of the device, then you use Control F. So let's say we want to find our input, so I 0.0.0, say find, and it takes you to that. So if I click on there and say find again, boom, it moves to that point. If you know the variable name, it'll be Control K. So I want to say stop, find next, and there it finds it by variable name, not by address. If I had to punch in I 0.0.10 in there, you say cannot find item because it's looking for a name or text. But you have the option of find device, find text, and also find and replace as well. Now, let's delete this again. Now, these are just using digital inputs, digital outputs. But what if we want to have variables? We've got analogs. We want to view analogs. We want to view temperatures. We want to write speeds to VSTs. Now, how does that work? As you remember, in our I/O parameters, we created our analog input, our analog output. So how do we access those? How do we view our inputs? So very simply, I'm just going to create a little comment here to say read analog input. Say okay. So now a very popular block that I like to use is a move block because it's quite a universal block. So I'm just pressing F10 to open up my function blocks. I want to say move, because the move can look at anything. It looks at arrays, it looks at any variable that can be used. So I use a move block just because it doesn't require an output. So you got your in and your out. It doesn't require an output for it to be healthy. So I want to view what my analog input is. So if I had to double click on here, now remember the analog inputs and outputs and I/O parameters all registered under global variables automatically because you want to be able to access it anyway. So in here, you click on global variable, and here it gives you the list of analog inputs and outputs. So as you can see, it shows 4 here because if you go back to I/O parameter, slot 4 is your analog input, slot 5 is your analog output. So if I had to double click on there again, I can actually filter it as well. We can go to slot 4 for analog inputs, and these are just your analog inputs. So it's got here variable global 04 channel 0 data. So that's your channel 0 analog input. There's your channel 1, channel 2, channel 3. So if we had to double click on this, this puts in here analog input channel 0 data. So that will give you your raw value of your analog input. So this value that's going to come in here, if you're monitoring, will give you a value from 0 to 4,000. So as your pressure changes or your temperature changes, any analog input that you got coming into the PLC will give you a raw value that's coming through there. So I use this basically as my move block just to test that my values are coming in initially. Before I do any scaling, I check, okay, we've wired up. Have we wired up correctly? Are we reading the values? Is the sensor working correctly? If my value is changing here, that means that everything's healthy. Now, what we can do, what's nice in the XECU, it has a scale block. So I'm just going to press F10 as well. Type in scale. Say OK. So it gives you what the scale block requires. So scaling is X is what is your value, your analog value. I want to take it from there. I'm going to copy that, Control C, Control V. Just going to do it this way. Okay. Then what's your X maximum? We said it's 0 to 4,000. So we're saying 4,000. Your X minimum is 0. Your Y max. So let's just say it's temperature, and our temperature range is from 20 degrees. Sorry, that's a maximum. So it's up to 300 degrees. And our minimum is 20 degrees. So what that will do is at a value of 0, we're actually going to read 20 degrees. At a value of 4,000, we're going to read 300 degrees and automatically. So we want to tell, okay, here's our output here, say temperature scale. Now, as you can see here, it's an integer value because our analog input is a 16-bit integer value. So I want to leave that as. Okay, so I want that to be a local variable for now. Okay, integer variable. Okay. So what that means is that scale block's going to read the analog value. It's going to scale it between 0 to 4,000 because that is the value we're going to get anyway. So we don't need to change it. And it will scale your 0 to 4,000 to 20 to 300. Okay, and that output will be viewed in here. Now, this is a good example to test. Okay, we want to view this value here on our HMI, on our LS HMI. So obviously, these values need to be addressed. Now, as it's an integer value, how does the LS PLC address values, integer values, double integer values? So very simply, we're just going to say edit here again. As we saw earlier in the retain areas, we saw an MW. So MW relates to a marker word. So each marker word is a 16-bit value. Okay, so let's just say we want that value, our temperature scale value, we'll save it at marker word 0. So you start from marker word 0 all the way up to whatever the memory allows. You can actually put marker word 500 is purely up to you, but obviously as you structure your program, it'll make things much easier. So we'll say marker word 0, okay, and it tells you here now that temperature scale value is now addressed to marker word 0. So if anybody has any questions with that, please let me know, because a marker word is a 16-bit registered value that relates to integers, unsigned integers, signed integers in the program. And there's a nice little tool here that explains it a bit better. There's an address calculator. If I put in marker word 0, it tells you here, marker word 0 is equivalent to MX0 to MX15. Basically, MX is a bit. So as I said, it's a 16-bit value. So MX0 to MX15 is 16 bits. MB is bytes. So each word is 2 bytes, MB0 and MB1. It's already marker word 0. And MD
Sorry,
is
Devin?
marked. Yes, go ahead.
Are we supposed to be seeing something on our screen now with that calculator?
Oh, you're not seeing that?
No, I'm just seeing your program.
Okay, I'm not sure why that's popped up. I think the way the share actually works on these things. Okay, let me see if you can see that. Can you see that now?
Yeah, I can see that.
Okay, so I just typed in marker word 0 in there.
Where did you
So,
get the
yeah.
address calculator from?
Under tools,
Yeah.
tools address calculator.
Okay.
Okay, so marker word 0 is from MX0 to MX15. Those are MX1, MX2, MX3, all the way up to MX15. So marker word 0 is a 16-bit register. And I'm not sure if you remember your digital system. So each word is 16 bits and 2 bytes. So that's what this pretty basic explains here. It's MB0 and MB1. So if I had to type in marker word 100, it tells you it's from MX1600 to MX1615, and marker byte 200 and marker byte 201. Now we also have double integers, which is your 32-bit registers. So if I had to do MD10, for example, it tells you it's MX320 to MX351. So that's 32 bits. And now it's 4 bytes, 40 to 43. It's now 2 words, 20 and 21. And MD10, and it's long 5.0 to 5.31. Okay, sometimes that can be a bit confusing. Okay, I'm just going to close that for now. Share my actually 5,000 again. Okay. So now this allows us to address that value into our HMI to view. But now there's also ways of us wanting to start and stop functions via our HMI. So we don't want to be able, don't want a physical input that starts. You don't want a physical input that starts our motor. You want buttons on the HMI. So obviously you don't need a physical input that you need to wire up, and you don't need to address. So how do we address that function into an HMI? So I'm going to say, I'm going to create another little comment here to start system via HMI. So I'm using an HMI as an example to show how we address it so that we can link the HMI and the PLC together. So I'm just going to put another normally open input contact. I'm going to say HMI start. Okay, so once again, it's obviously going to be Boolean because it's an on-off. But now this is where the addressing changes. As I put in marker word 0 to read my temperature on my scaling block, now I need an address that's gonna, a bit address that's gonna start by the HMI. It's exactly the same, but marker word 0 now is already used, so we won't use that. Let's say we use marker word 10. But now marker word 10 is an actual integer value, but we need a bit to start. The Boolean is a bit, it's a start, it's a on or off. Now marker word 0 is a full 16-bit register. We just need 1 bit from that register. So to get the bit out of that register, it's as simple as putting .0. So marker word 10 has 16 bits, marker word 10.0 all the way up to marker word 10.15. So by putting 10.0, we are using the first bit of marker word 10. I hope that's clear. I'm just going to see if I can do this quickly. Do you see the whiteboard? Okay, so we got marker word 10. Okay, that looks terrible. And that is a 16-bit register. Now this register can be broken down into 16 bits. .0, 10.1, all the way down to 10.15. So basically every register on the PLC can be broken down into bits. So if you need to read an analog value, you're gonna use the entire word, for example. If you want a bit for an on-off function, you're gonna break it down into its individual bits. I hope that's clear. Okay, let me share this again. Okay, so that's exactly what I did here. I took the first bit to start it. Now I want to put another coil. I want to say, I'm going to say motor 3 run. But now let's use one of our expansions on here. So this is our relay output on slot 3 of the PLC. And if you look in there, actually, if you hover your mouse over there, it tells you what the address is. The address is Q0.3.0. If you look at the last one, it's Q0.3.15. So it actually tells you what address you can use for the output. So I'm just going to click on there. And I'm going to say motor 3 run Q0.3.0. So that's base 0, slot 3, output 0 of slot 3. Okay. And then I'm going to give it another latch here. Click on motor 3 run. Join the line. And then I'm going to give it normally closed here and say HMI stop. And now I'm going to give it marker word 10.1. So that's using bit 1 of marker word 10. So you got 10.0, 10.1, Q3.0, 3.1. Now I'm going to simulate this thing just to show you guys what difference it makes when not using forced I/O, when not using a physical input or output. Okay. Okay. So as you can see, now we've got our start. But what's different is when it's a bit and not a physical input, as in I0.0.0, if you double click on there, you don't need to go to forced I/O. It's grayed out immediately. Say OK, and it closes immediately. So sometimes when we're programming and we don't have to do forced I/O, we can actually write it without even addressing it. Click on there to unlatches. And what I mean by not addressing it, stop the, this PLC allows you to give it a coil without any address, and it will work. So you can actually create an entire program without addressing anything. So you can test your program fully and then address later. But obviously that addressing later can take time. So if you want to, it's purely up to you as you program and get used to it, how you want to program. But the XG 5000 allows you to create an entire program without addressing anything. You can simulate your program, test all the functions, and then later on started adding your addressing in. And also without having to delete anything, you can just double click on there, say edit variable, and punch in your addresses. You can even go into, click on there, your local variables within your training program, and you list your addresses in there. So we can actually even double click in there and say marker word 10.2 without having to go into edit as well. So you can create all your variables, have all your variable names in there, and start adding in all your addressing later on. But that's purely up to you how you want to program. You want to add your addressing in in the beginning, which is what I actually normally do. And what I do is actually normally keep a spreadsheet as I add variables in, so I don't have duplicates. Although it does warn you, but I do like to keep an Excel spreadsheet as I program. Any questions so far?
Hi, Devin.
Yes.
Can you simulate analog inputs?
No, unfortunately not.
Okay.
Yeah, you can write a value, and then in that case, if you want to test that you're getting signals into your HMI and things, you can actually just write a value into your scale block, for example, just to see that you're getting values coming through, and to test if your scale box is working correctly. But unfortunately, you can't simulate analog values.
Devin,
Yes.
can you create and save the programs and later use them in the system
Yes.
without addressing anything? And then, as we've just had the question, if you need an analog input later on, put it inside?
Yes, you can. Yes,
Okay,
you can.
good.
So you can save your program, you can make changes, and then later on you decide to add in, even if actually you've got let's say you got a program running on site already as well, and you say, okay, I need a new analog inputs into my program. You can go in there, obviously physically mount another analog input card in there, register that in, and download into the PLC. So it's not.
All right. Can we adjust online, or we need to put the system off?
Well, in that case, by adding another card altogether, you would have to switch it off.
Okay.
Because that's a big change, yeah.
All right.
Yeah. But online editing is a huge thing, because of basically there's lots of plants I've been to where the guys cannot stop. But obviously that's not adding extra IO and things in. If the IO is already in there and there's another input you need to wire in, that's fine. You can do that, and you can add it into your program for something that's already there. But adding a new card in requires a full stop and a full download stop. Okay. Okay, so so basically, does anybody understand Modbus? Have they done Modbus communication? Because it's something, yeah, okay. Let me try and explain how Modbus works. So these PLCs support built-in Modbus. Okay, let's look at the XCCU that we are using now to play with. It supports Modbus RTU, which is a serial communication, which allows you to communicate to any Modbus device, like our VSDs, for example, or Modbus TCP, which is Ethernet Modbus. And that allows you to communicate to different Modbus devices only. So if a system like our VSD support Modbus, lots of our systems, we digitally start and stop a VSD, but we control the speed via communication. So that saves you a whole bunch of wiring and things. So there's certain systems where the entire system is communication. There's literally just an Ethernet cable between each drive to start and stop it, control the speed. And we've actually even done that with the Siemens SIMO codes as well. But in that case, we're using Ether-IP communication. So we've done a whole range of communication that these PLCs do support: Profibus, Modbus, Ether-IP. Yeah, we've actually done almost all the and we've spoken to all different types of PLCs as well: Allen Bradley, ABB, Siemens, with the LS PLCs talking to those PLCs. But what we will touch on now is the Modbus communication, because it is the most common. And this particular PLC does support Modbus, and we look at the Modbus RTU portion of it. So if we had to go into our project window, double click on internal CNET, and we can use channel 2, which is our 485 for Modbus. Let me say use P2P. So P2P is peer-to-peer communication, which is what is used for Modbus. And what I'm going to do is I'm going to use our VSDs, the LS VSDs, as an example of communication. So to say OK, then I'm going to right-click on internal CNET. I want to say add item, and I'm going to say use P2P communication. Tells you it's going to be P2P01. Say OK. So as you can see now, let me just pin that. What it's done is it's added another pull-down menu for P2P01. I can pull that down even further, and now you got P2P channel, block, and user frame definition. We're not going to do user frame definition now. We're just going to use the P2P channel and the P2P block. So if I had a double click on P2P channel, as you can see here, because I've selected P2P earlier, it shows up here under channel 2. And I'm going to tell it I'm going to be a Modbus RTU client. Say OK. Driver is changed. Existing blocks will be automatically deleted. Confirm to continue. Say yes. And now if you had to double click on the P2P block, it gives you 32 blocks for communication. So these blocks are your communication blocks to talk between your PLC and your VSD. Obviously, well, you will have to have your communication cable wired up between your PLC and your VSD. Okay, so we're going to say channel 2. And as you can see, it automatically put the driver setting as Modbus RTU client. Your P2P function is, do you want to read from your drive or do you want to write to your drive? So for now, let's say we want to read from the VSD. So we want to read the current from the VSD. So the conditional flag are the flags that are built into the PLC. So is your polling time, is your pulse rate. So you're polling between your VSD and your PLC. That's what your conditional flag is. So our PLCs have built-in flags from 20 milliseconds up to 60 seconds. So we're just going to say, and the way the conditional flags work are, it's an underscore, T for time, and then I'm going to use the 1 second flag, 1S. So that is every 1 second, it's going to poll the VSD for information. The command type, let's say we want it to be the difference between single and continuous. Single, it'll look at one address that it wants to read from the VSD. Continuous, it'll look at multiple consecutive addresses that it wants to read from the VSD. So for now, let's just say we just want to read the current. So we say single. The data type is going to be a word because it's an actual integer value, the current. Destination station, the first drive address is going to be address 1. Click on setting. So under this is where Modbus addressing becomes interesting. You got your read area. So as you can see, it's already put in a 3 in there. The 3 in when it comes to Modbus means read. If there's a 4 in place of 3, it means write. Read integer value, write integer value. Just want to open up my drive manual quickly, so you guys can have a look at that as the Modbus addressing in there. Okay, let me just open this quickly and let's get to that point, and now I can open that in the screen for you guys. So give me 1 second. Sorry about that. This manual didn't open properly. Okay, there we go. Okay, I'm just going to share this with you guys now. Okay, can you guys see this?
Yeah, we can see it.
Okay, so these are, let me just make that a bit smaller. So these are your Modbus addresses for your PLC. So example, I wanted to read the current. As you can see, output current here. And this is your Modbus address right here. So it's 0009. So that address is to read the current. So if I want to read output frequency, I would read 000A. So it's a hexadecimal value that the Modbus, that the LS Modbus requires. So some devices, like sometimes a Moxa device, they give you decimal Modbus addresses. For it to read on LSPLC, you'll have to convert it to the hexadecimal. The built-in Windows calculator actually does that conversion for you if required. So we want to read address 9, which means that we want to read our output current. Now, also, strange thing about Modbus, which I've obviously with experience that comes through, that sometimes there's offsets. I don't know why that is, but sometimes Modbus has positive offsets, they have negative offsets. And in this case, the LS actually looks at a negative offset when it's doing Modbus RTU, meaning that although the address here shows that it's a 9, we are actually going to read 8, a negative offset. So although we're going to say address 8, but it will read output current. Now, the strange thing is if you do use Modbus TCP, which is an Ethernet connection, there is 0 offset. And if you're going to read output current, you would read address 9. So for now, we're just going to be using RTU, so they will have a negative offset. So let's get back into our variable setting. So in here, as I said, so it says 3 for the read, and we change our address in there to 8. And then the save area is what address are we going to save it to on our PLC to read. So as we were talking about marker word addresses earlier, that's exactly what we're going to do now. So we want to read the current from the drive on address 30008, which is your Modbus address, and we want to save it. In this example, we'll save it to marker word 100. Say OK. So as you can see, it's going to read from channel 2. It's going to be a Modbus RTU client. It's going to read every second. It's going to ask for data. It's going to read one word only from station 1. So if you have multiple VSTs, each one will have its own address. All will be connected together, but will have individual addresses. Then when you click on setting, it's going to read from that Modbus address 30008, and it's going to save it to mark word 100. Then if we go back into our PLC program, put another comment in here, read VST1 current. Once again, I use my famous move block just so that I can read my value. I'll double click on there and I'll name it VST1 current. It's going to be an integer value because it's a 16-bit value. And I'm going to say, and as we named it in a block, mark code 100. Okay. And very cleverly, it's changed the color of the variable to orange, which means that it is a communication address. So it tells you, okay, it's orange because it's a communication address, and it's something that has been used there. Okay, so that's to read the current from the VST. Now we want to give it speed. So we say 2 again. Now we want to write. Again, we want to do it every second. and once again, single, word, destination 1, setting. Now it's where we want to read from the PLC and write to VST. So I'm going to say I want to from marker word 101 and address. So let's go back into our, let me show you that address. So we go back in here and we say command frequency. It tells you here command frequency, and that's on address 5. Once again, it's a negative offset, so I'm actually going to have the address set to 4. Go back in here. So as you can see, it's right. It's already changed that first address to 4. And it's address 4. Okay, so that means now we're going to put a value into mark word 101. It's going to write to Modbus address 40004, and it's going to give the VST a speed. So I'm going to say, give another comment here. Say write speed to ST1. So I'm going to say F10 once again, move. And I'm going to say ST1 speed. It's going to be an integer value and marker word 101. So what that means is, again, you see it's orange because it's a communication address. If I had to change that value, let's go into simulation. Obviously, we're not really going to see this now because we're not connecting to a VST either. Say OK. And if I had to double click on there and tell it a value of 1500, what that's going to do is that's going to write a value of 15 Hertz into the VST. If I wanted 50 Hertz, I would write a value of 5000. But obviously, you can actually make that dynamic in your program based on temperature, based on pressure. You can make that value change according to your analog input. So as your pressure increases, you make the drive slow down, and so on and so forth. Okay, so that's your Modbus PTP communication, a very basic portion of it. Obviously, it can get a lot more complicated because literally almost every parameter on the S100 drive is accessible via comms. But must remember that you are limited to 32 blocks. So if you require a lot more VSTs they have in your system, you're gonna have to purchase more communication cards to assist with the extra VSTs and extra data that you want to read from the system.
Sorry, Devin, can you just quickly do an example of reading consecutive addresses and maybe saving them to a marker word to display it on an HMI, for example, voltage, current, and frequency?
Yes, okay. Okay, I'm just going to open up the manual here again. Okay, so if we want to read, what I'll do is I'll change we'll read frequency, output voltage, DC link, and output power. So you can see that's from address A, B, C, D. Obviously, it's going to be an offset, so it's going to be 9, A, B, C. Okay, so that's from address 9. Let's go here. So once again, we say 2. We want to read. Let's go T 1 second. Now we're going to say continuous word. Now because it's a continuous, it tells you what, it asks you how many words you actually want to read. So we're going to say 4 words from station 1. Now, once again, we're going to read from address 9. And now we've already used mark word 100. We use mark word 101. So we're going to say mark word 102. Say, okay. So what this is, we're going to read our output frequency our output voltage, DC link voltage, and output power. So how that works is now we've set 4 words. So I'm going to say read PST1 data. So I'm putting another move block in here. And that's going to be PST1 voltage. Sorry. It's going to be an integer value, and that's going to be marker word 102. Then let's just create another move block here. PST1 out for DC link. Obviously integer value again. So I'm just using tabs, mark word 103. And that's going to be PST1 power. Integer again, marker word 104. So I'm just doing 3 for now. That's fine. Okay, let's do the last one. It's fine. It's just one more. Okay, so those are the 4 words that we, as we said, our start address is 102 for 4 words. So it's 102, 103, 104, 105. That's your consecutive words that we've told it to read. And that's the 4 addresses in the PST manual. So what you can do now is you link these addresses to your HMI. You don't need to put it into another address if you want. If you want to, you can put it into another address, but you don't have to. For any reason you decide, okay, I want to keep the comms addresses on their own. But as I said, it's not entirely necessary. But as an example, you want to give your HMI a different set of addresses. So HMI out vote has to be, the in and out has to be the same. It won't work if it's not. And we can say our HMI address is going to be on marker word 200. So that's how it's going to work. So VST1, if you're reading from your VST on that, and you're going to send it to your HMI to that on that. Well, as I said, you don't have to do that because your HMI can read the marker word 102 directly anyway. Okay, any questions? Everybody happy?
A quick one.
Yes.
I don't see those orange VSD1 speed or current, etc. on my program when I put them in.
Have you?
So I've only got the top one in.
Yeah.
The top line index 0.
Yes.
And it says in the end, read 1 colon 0x30008 save 1.
Yeah, 100.
100. So it
Yeah,
says,
and is marker word 100 orange on your PLC program?
so I've just deleted it and I'm gonna, so you double click next to the in, right?
Yes.
And on variable, I just put MW100.
No, you actually, no, the variable name changes color, not the actual address. So if you have to give it a name, the name changes color. So as I got your VST1 current, that's the one that changes color, but the actual physical address does not change color.
That's the lesson I was sleeping in.
There you go. Okay.
Okay, thanks.
Okay. So that's a basic Modbus RTU communication. TCP works in almost identical fashion, just that using Ethernet instead of serial. But it's the same block, it's the same P2P. just that in this case, with TCP, you actually don't need a destination number because each device has an IP address. So it's not critical in that sense. Okay. So the next two important functions of the PLC and it's built in is our high-speed counter and our PID. So I'm not sure how many guys understand PID, but okay, let's start with the high-speed counter first, and we can go into the PID. So the high-speed counter basically we use for mainly for encoders. But recently I used it for a system where it actually rotated a tin and the sensor picked up the seam to know when to stop. But the tin turns around pretty quickly. So there was a very small pulse that came through from the sensor. And if you wire it up as a normal input, it won't pick it up. It actually just kept on rotating the tin because it never saw the input. So we wire that up into to a high-speed input. On the PLCs, the first 8 inputs are high-speed inputs. The first 8. So obviously, remember, if you're going to be using a system where you've got an encoder or a sensor that requires a high-speed input, the first 8 are high-speed inputs. But it's only high-speed if you enable it, if you tell it that it's a high-speed input. So you can wire them up as normal, which is fine if you don't require high-speed inputs. But just remember that if you've got a project that requires high-speed input, you can use anything from 0 to 8. So, but as I'm going to show you in these parameters now, very importantly, you got your linear and you got your ring. So linear is generally what we use most of the time. So it counts from 0 upwards on channel 0. But let's say we want to count clockwise and counterclockwise. So what's important to remember, if you're counting forward and counting back, let's say an encoder on a table drives the motor forward and drives the motor back. So you need to know what position it's in. Sometimes we use encoders for, let's say, when it drives something 100 mils forward and then another 100 back and that sort of thing, or to bring it to a home position. When you say clockwise and counterclockwise, automatically it grays channel 1 out. So what that does is, from being an 8-channel high-speed input, and if you had to use all channels as clockwise, counterclockwise, it brings it to a 4-channel. Because input 0 will be used to count forward, and input 1 will be used to count reverse. So in this case, though, let's just say we can use it as a normal forward count only. Because sometimes we've used systems where we just cut to length system, so it just drives in one direction. So it's fine. So we'll keep it in there. So so you wire up your encoder, and your encoder is a 1024 pulse per revolution. That's where you punch it in, and you can say, okay. Now that's just telling it how many pulse per revolution encoder you have, but how do you tell it that you are using that input as a high-speed input? So let's just say here, I'm just going to give it a high speed. Now we want to enable high-speed input. So I'm just going to put F3 here. And you can see we got flags. Flags are built-in functions of the PLC. It's all addresses that are built in. As you can see, there's a whole list here on the system. And this is where you find your conditional flags, your clocks, 20 millisecond, 100 millisecond, 20 millisecond, meaning that let's say 1 second is an example. It's 1 second on, 1 second off, 1 second on, 1 second off. So it's a clock. That's all it is, up to a 60-second clock. In this case, I'm just going to use an always on block, because what I want to do is I want to enable my high-speed counter. So I'm going to say, put a coil in there. Going to say flag again because it's a built-in function, but you list your built-in functions. We say high-speed counter. So now it lists every single channel. Now we don't want to look at every channel. We just want to look at channel 0 being input 0. So click in there. Actually, sorry, let's not use input 0 because we've used input 0 on there already. 1 is used, 10 is used. let's use input 5. So I'm going to go back to my high-speed counter. So set that, well, it actually doesn't matter unless you activate it. I'm going to go to input 5, so 1024. Okay. I want to switch that on. So I'm going to go to high-speed counter. I don't want to look at all. I can untick that and say I want to look at channel 5 only. So now here it tells you count enable, internal preset enable, gives you the whole list of functions related to a high-speed counter for that channel only. So I'm going to go to high-speed counter 5 and enable it. So that means now input 5, this is an always on flag that's built into the PLC, meaning that that'll always stay on no matter what. And that will keep that output on. Technically, I don't have to do that. I can actually just give it a normal line and we'll keep it on. But as a personal preference, I like to have that there to know that I find it looks better. it's a bit arbitrary, but yeah, it just looks better. Okay, so that enables a high-speed counter. That's all it does. Now you want to view what your count is. Once again, I use my move block. Click on there. Once again, it's under flag, high-speed counter, channel 5. And I am going to look at my current count value. Double click in there. So what happens is now, as long as that's enabled and your encoder starts to turn, input 5 will start flashing really quickly and that'll start counting up. If you wanted to stop counting, you can disable this input, it'll stop counting. But let's just say it's a continuous process. It's a sheet of steel that's going through. It needs to slow down. Guillotine needs to come down and cut. So that value will count. You can scale it obviously to millimeters as you go along. That's purely based on the project itself. So that's going to count to a certain value. You can tell it that if it gets to a certain value, stop and cut. So how do we do that? Very simply, we have compare blocks. So we have greater than or equal to, we've got less than or equal to, greater than, less than, or even as simple as equal to. So this falls all under the comparison block. So equal to, greater than equal to, greater than equal to double integer, which in this case will be required. Greater than equal to integer, greater than, and so on. So let's just say we want to say greater than or equal to, which is fine. And we can take this value, put it in there, and we can have a value if it's greater than or equal to 10,000. There's an example. If it's greater than or equal to 10,000, give it an output to say stop. Or we'll say cut. So what that means is when this value counts to that point and it reaches above 10,000, we want to cut. But then obviously we need to reset it as well. So what we can say is when the cut pulse comes on, cut is already there. We want to reset it, and very simply, we can go back to flag, high-speed counter, channel 5, and we want to activate the internal preset. So what that means is this will count up to 10,000, it'll cut, and when the cut comes on, it'll reset based on the internal preset. If we go into our parameters, let's go to channel 5, our internal preset value is 0. So if you want to preset, you want to reset to 10, for example, you can turn your internal preset to 10, then it'll start counting to 10. Start counting from 10. But generally we leave that at 0 just so as a reset. But if you want to put an offset in, for example, you can actually do that, a 5 mil, 10 mil offset. based on the project. Okay, so always enable the counter. And here, just to view the counter value, and here it's a little compare block to say, okay, if that counter value grows greater than 10,000, cut. But remember, on a project, and if you're doing a cut length system, that value can change. So you can change this value and give it an address. Let's just say HMI 10th. So you're going to get that value from the HMI. Remember, an encoded value, because it can be so big, it's actually a double integer. So we actually have to match it. As you can see, the value is KD1096, KD meaning double. So you can say double integer. And then how do we address the double integer? So MW10, or let's say 500, that's not going to work because it's a 32-bit value. So MW, so you can see that there. It says variable address notation does not match variable type. That's meaning that the double integer is not an MW. An MW is a 16-bit integer. A double integer is a 32-bit integer. So to get that correct, it's MD. So I'm going to say MD 200. Say OK. There it matches in there. So once again, if we use our calculator, you'll see that MD200 uses marker word 400 and 401. Okay. So that's basically a little high-speed, a very simple high-speed counter control system. So you count your value. If it goes greater than a certain value that you've added into HMI, cuts and resets, and then starts to count again. Okay, so the next complicated one is PID control. So PID control is built in as well. And it says you got 16 loop PID. Scroll through here, you got your 16 loops of PID. You got auto operation or manual operation, but generally a PID you want it to be in auto. Then you got forward or reverse operation. So like in cooling towers, you actually want reverse operation. You want your fans to speed up to cool. Then you got PWM output as well. So PWM is a high speed output. You need a transistor output for that. Lots of guys use that for temperature control using solid state relays on elements. So we've actually done this for a few customers as well. So we use PWM control. So the high speed output goes on and off to control a solid state relay on an element. So the way PID works is, let's say example, you got a 300-degree set point, your current temperature is sitting in 50 degrees. PID will switch the output on the PWM function. We'll switch the output on, keep it on until it gets close to temperature. And as it approaches temperature, it starts switching the solid state, excuse me, starts switching the solid state off and on, off and on, off and on. And it starts pulsing it and slowing it down until you get to temperature. And when it gets to temperature, it'll switch the output off and then pulse every now and again to make sure that we don't lose temperature. The other PID control is purely through analog control, where you see your maximum and minimum MV that's on here. So basically you got a value of 0 to 4,000, which you can use to control proportionate valve using your analog output. So as your value changes, you can your valve will change as well. So you can use PWM for your digital high-speed digital output, or you can use analog, an analog output of 0 to 4,000, which equates to 0 to 10 volts or 4 to 20 milliamps to control a proportionate valve. As well as you got your PID values that you can change to control. So your proportional control, your integral time, and your derivative time. 99% of the time we don't use derivative because it tends to throw your PID off. We tend to play with our P and our I values, your proportional gain and your integral time. Then obviously you need a set point, you got a set value, and you're going to have a process value. So your set value is your set point, what you want to get to, your set point of 300 degrees as an example, and your process value is your actual temperature, your analog input. So I'm just going to do a little example now. So firstly, we want to punch in our set value. So we can say, I'm just going to put another little move block in here. And we want to get the set point from the HMI. So I'm just going to say HMI SP set point, integer value, and we're going to read it from marker word 25. And just say, give it a description as well, temperature set point. Integer. Okay, so temperature set point, and then we want to write that. So once again, it's going to go back into flags system. This time we're going to go into PID. I just want to look at loop 0, not all the loops. And then we find the set SV, PID set value. So that what that does is, from your HMI, you're actually going to write, let's say your 300, you're going to punch in 300 in HMI, and it's going to write that value into your set value of your PID, built-in PID into the PLC. The PLC also needs to read, move here, also needs to read, excuse me, needs to read the process value, which is your actual temperature, which will be your analog input. So we can double click on there once again and say, this time we'll go to our analog input. Now let's just say channel 1. And this we want to move to our process value on our PID. Excuse me. So this, our HMI gives us a set point into the PID of the PLC, and our analog input gives us the actual temperature. So you got your set value and your process value. Then you also want to be able to change your PNI values. Excuse me. Sorry about that. Okay. So once again, I will use my famous move block. I'm going to say HMI P. Now, your PID values are real numbers. So if I had to, and I can see you are real numbers. So I'm going to go in there. I'm going to say HMI P. I'm going to go in here. I'm going to tell it it's a real number. Because it has to be so precise, you can go up to, down to decimal points. This is why we actually use real numbers. And then you go into flag, go to PID, station loop 0 again, and KP. So that writes from the HMI in a real value to a real value for your P value. Let's put in the I value, HMI, again to real. And your I value. So you can change those values as you go along, because PID, if your proportional is too high, you can overshoot and constantly hunt. And if your I is too high, then it's going to take a long time to actually get to set point. So PID does require fine tuning. Let me just draw a little diagram for you guys to get an idea. Clear all this. There's a little clear button. Okay, so PID works in this sort of fashion. So you got your set point, which is your set value. Let's say is 300. And we want to get from, let's say this is already at 50 degrees here. We are sitting at 50 degrees currently, and we want to get to 300 degrees. So you activate your PID, the system will come on, and based on your PNI settings, your temperature will start to increase. The ideal PID is to increase and then match your set point. Now, if your value is incorrect, you can spike and go too high and overshoot and then constantly try and hunt and eventually try and get to set point. So that's why when it comes to PID, tuning is actually quite critical in the system. The system does support auto tuning, but it purely depends on the process itself, because sometimes processes are so reactive that it's easier to manually tune, and some systems are so slow that it's easier to manually tune. Whereas systems where your temperature is going to work quite steadily, and auto tune works quite nicely. So if you have very high integral time as well, what can happen is that your temperature can stay low for a long time and take a long time to get to set point. So in your PID settings, you can tune your PID, and as I said, the PLC has 16 loops, so you can have multiple PID settings for different functions of your machine or whatever your machine needs to do. Okay, anybody have any questions? As I said, these are just basics of basic built-in control of this thing. Obviously, when you guys need to use it and you're struggling, then I will help you guys. That won't be an issue. And we can work on it together as we go along. Okay. So I think we've covered our introduction. We've created a new project. We've shown methods of communication, IO allocations, function blocks, how to download, searching, monitoring, how to force IO. Oh, we haven't done upload, how to upload from the PLC. Fortunately, I don't have a PLC here, but very simply, it's done by a project open from PLC, as simple as that, and you can upload from your PLC. There's nothing fancy about that. Obviously, if you got USB connected, then you can select what sort of function you actually are going to use. So I can use USB, 232, Ethernet, and it'll read from your PLC. Okay, does anybody have any questions? Any questions?
None from me.
Oh, good.
We'll just have to work through this again. I see your recording, so I assume we can look through
Yes,
this.
definitely. And then also, if you guys are struggling, you have my number, give me a call, we'll go through it. If I'm not available, I have other guys that can help as well. So we definitely will assist. We don't just sell we don't just sell a PLC and say, no, it's up to you now. so we'll assist as far as we can, yeah. You guys want to take a break for like 2 minutes? And then we'll go over the HMI.
Great, thank you.
Okay, yeah, we'll come back at about 4 past. If that's okay.
Thank you.
Fine, yeah.
Okay, thanks. Okay, see you guys at 11:15.
Thank you.
Thanks. Yes.
Devon, so we have a 10-minute
Fine.
10-minute break.
Yeah.
We have a 10-minute break, or
Yeah, till 11:15.
all right, good.
Yeah, we'll have a 10-minute break till 11:15, and then we'll tackle the HMI. The HMI is going to be very quick because it's too much to go over for a basic course. We're just going to go all the basic stuffs, but how to set up a few things, and then we'll take it from there. We'll do
All
it
right,
very quickly.
good.
Okay. Yeah. Thanks, Rudy.
Okay, thanks.
Yes. Hi, everyone. Can we start?
Yes, I think so.
Okay, correct. Okay, so we're going to go through XP Builder, which is our HMI design software. When you open up, the first thing you're going to see is create project to open project. So obviously we are going to be creating a project. So if you click on create project, it gives you the list of IXP, or a list of LSP or LS HMI series of HMIs. So we're going to be working on the EXP, which is our most common seller. And we have from the EXP 20, which is a little 4-inch, up to the EXP 60, which is the 10-inch. So we'll select the EXP 60 for now. And it gives you the specifications of the screen. It's the 10.2-inch, 800 by 480 pixel, 65,000 color, 4 meg memory. So quite a nice little screen. What's important as well is your vendor. As you can see, if you pull down your vendor, you have a list of vendors that you can actually select. You don't necessarily have to use an LS PLC to do this. You can use a Delta PLC, you can use the Siemens PLC, Rockwell, and even Modbus here as well. So there's systems where we actually don't even have PLCs. We're going to HMI connected directly to a VSD. And the HMI starts and stops the VSD. It views the speed. You can set the speed just using Modbus. But in this particular example, we're going to stick to the LS as a vendor. And once you pull down your product, it gives you the list of LS PLCs that you can communicate with. We're going to be using as a test XCC Ethernet. So we can link to our XCCU PLC over Ethernet as well. So once you select that, then you can click on communication settings. They'll pop up. And it tells you once again, you can add multiple controllers to your unit as well, but we'll keep that for the more advanced courses. So we're going to make a LS product, LS Ethernet, protocol Ethernet, and then we can go detail settings. And this IP address here is the IP address of the PLC that you are going to connect to. So it's not the IP address of the HMI. The IP address of the HMI is set on the HMI itself. So when you initially power up an HMI, it comes up with the engineering menu screens where you can set your IP addresses, your timeouts, your connections, and that sort of thing, all in those settings. Even do calibrations, touch calibrations, color calibrations, and that sort of thing. Well, color tests. Say okay for now. And a nice little thing here is called Use PLC Simulator. And what's awesome about that is, without having a physical HMI or PLC on your desk, you can actually start your PLC simulator, start your XP Builder simulator, and the two systems will link. So we're going to tick that for now because we will be using it. And then we got our screen settings. Screen settings tells you which screen number you want to start at. So if you are programming, you realize, okay, my main menu is now sitting at screen 10. You can change that initial screen number. So when your HMI boots up, it'll go to the screen number that you specify here. But once again, in the engineering settings of your HMI, you can actually set that value there as well. Then you got security settings. This is where you enter your passwords. So you got multi-level passwords. So you can actually set it to that level. So at level 1, you can say it's supervisor only. At level 9, it can be engineering only. So depends how you design your screen, certain functions can only be accessible to different people based on the passwords. So we can, for example, I'll just put 1, 2, 3, 4 now. And what I normally do as a preference, I set this down to 0. So basically it's your password interval time, input time. So what this means is I set it to 0 so that every time the guys need to go into the screen, they have to punch in the password again. Whereas if it's at 3, basically after the 3rd time we're entering the same screen, that's the only time it resets. So I just set it to 0 as a personal preference. In your key window settings are built-in keypads. So if you look to the left as well, you go to decimal, hex, ASCII. Those are all windows that pop up, automatically pop up if you want to enter a value or whatever it is. Then languages. Obviously, we are South African, so we generally stick to English, UK. We can delete the other fonts if you don't need it as well. Up to you. Storage settings. So generally, everything's stored to flash memory unless you want to store your alarm data, logging data, recipe data. You can select into USB, SD card. But remember, these are purely based on the model. So your EXP does not have a CF card or SD card. It does have USB memory. So you can plug in a USB card in there to save your recipes. Then you got global script settings. So the HMI support and XP Builder supports basic C programming for scripting. Extended device settings for barcode scanners and printers. Operation logs if you want to log that data. WXP is it's a remote access, which we don't. We have another piece of software called XP Remote, which is much better than WXP, because WXP is actually not free. So I recommend using XP Remote, which is free piece of software. So XP Remote allows you to connect to your HMI remotely and control it remotely via your PC or laptop. Okay. Yeah. Okay. So what we have now is our base screen. This is what it starts up with. I think when the guys initially install, I tend to take out my grid, but it will look like the way it is now. And you can, once again, on XP Builder as well, you can pin and unpin your toolboxes, your script toolbox, your figures, your objects. You can pin it same as your object, your screen information, your project information, and your graphic library. So you can lay it out as you want. It's purely up to you. Each person has their own preferences. So I tend to keep my grid off because I think it looks cleaner, but it's up to me. Sometimes the grid's handy when you're trying to draw lines and designing your screen. So in your screen window, what it tells you is your number one base screen. That can be renamed. So if you can right click and say rename, but importantly, it must have a number or it doesn't know how to allocate it. So you can say M main screen as an example. And if you need to add another screen, just double click on insert base screen. And you can say rename that as well to settings. And you can add as many base screens as you want. Okay, so if you want to add window screens as well, you can. So window screens are used as pop-ups as with the keypad. So I had to double click on this here. This is the built-in keypad that they give you, and that pops up whenever you got a numeric value that you want to enter. Okay, so you can close that for now. So we've just created 3 little screens in here. So that's how you insert and name your screens. Very important to name your screens. I've actually went on a breakdown for a project that another customer did, and literally the system had about 40 odd screens, and every single one had one base screen, 2 base screen, 3 base screens. So trying to fault find and get to the screen that you want, I had to go through almost every single one to find what I needed. So if your screen's properly labeled, that's good engineering practice. It makes things a lot easier to fault find. So project summary, XGT panel settings, and extended device settings were all under the settings. And then we have under the project tree, we have text tables. So text tables are handy when you have alarm lists. If you have statuses that you want to display, instead of having typing it out each time, you can create a text table. So if you had to double click on a text table, it'll give you an entire table with a whole list of text that you can put in. Once again, you can label it as well. Must have a number in the front. So I'm going to call it TXT alarms. So you can put in here VSD1 tripped, VSD2 tripped, E-stop pressed, thermal panel, thermal. So you can have a whole list, and obviously you can change the colors of the text and that sort of thing, italic, underline, strikeout, bold, etc. And then you can have multiple alarms, multiple text tables. We can call this one status, for example, and just say running, stopped, alarm, etc. Okay. Now that's to create, obviously, when you're having alarm, you create an alarm table. We'll go through that just now. This is where you can reference your text table. Now, very importantly, when programming it, especially when it comes to HMI, we have tag lists, which is nice and handy to, it's very important to use. It's not critical to use. It's not always necessary to use, but it's, once again, it's good engineering practice. So if we had to double click on tag, it gives you a default tag name, and it gives you a system. So system is what's built in to the screen, what's in the screen memory already. So once again, as you can see, it's got its own flag, similar to the PLC. You can use this when you want to run a script and look at, you can give it status if the battery is low on the HMI and that sort of thing. You can give yourself warnings with the built-in information from the HMI. But tags is your addressing that's linked to your PLC. So when I create a new group, you can right-click on new group, on tag group, say new group, and we can say these are inputs. So remember on our PLC, we had the start button. Okay, let me show you this. This does not require underscore. You can put spaces in there, which is fine. It doesn't have to match the same name as your PLC. It can be anything you want. The thing that has to match is your input, your address. So the start button was input 0.0.0. The stop button was input 0.0.1. And I think the e-stop was I 0.0.10. You can give it a description there as well if you want. That's, once again, it's up to you. Tag group, create a new group. We can call it settings. Check something quickly. And we can say motor VSD1 speed. And that's going to be a word because it's a register, it's an integer value. And in our HMI, we had that setting that speed at marker word 101. So now when you're creating it, adding these things into your screen design, you don't have to physically type in the address every single time. Now you can just refer to your tags and just add your tags in directly. Okay, so we're not going to do scheduling for now. Logging. So this HMI supports logging as well. So if you had to double click under there, you can select under what device do you want to log. So let's say we want to log a word and we want to log, actually let's say a bit, and we want to log. We can click on tag and we can go to inputs and we can say start button. So what that means is every time somebody presses the start button, we can log it. We can set that to 2. What it'll do is it'll look at input 0 and input 1 consecutively. So it'll start at input 0. So every time somebody presses the start button, it'll log. Every time somebody presses the stop button, it'll log. If you set it to 2. So now we just set it to 1. So every time somebody presses start button, it'll log. logging condition, how often do you want to log, every hour, or you can even log it with the start button itself. So every time the start button changes state from off to on a rising edge, it'll log it. Or if you want to, you can use a conditional flag as well. So log every single time, go to system, say every second, log the status of the start button. Then here you can actually say, I'm going to log it to USB memory. So you can use a ring buffer. So what ring buffer does is every time the memory gets full on the HMI, it automatically downloads it to the USB. If you leave ring buffer out, it's gonna get memory is gonna get full, and it'll not log anything else. So ring buffer will, once memory gets full, it'll dump to USB, dump to USB, dump to USB. And a new feature that's added with the latest version of XP Builder, we've added the PDF option. Previously, you could only log to a CSV Excel file. Now it logs to CSV and PDF. So if you don't have Excel or anything on your laptop, then you have that option as well. But the setting is still done via a CSV sort of format. So you can tell it number, status, the date. So you can design the way you want your list to look at. Right now, we're just looking at one bit of data. If you had to add multiple data, you'll have data 1, data 2, data 3, data 3, and so on and so forth. Okay. A log on common property. So all this does is it tells you how much memory you are going to use. So for a single bit, one device, and I want to repeat it every 50 times, it tells you that I am going to be using 1,224 bytes of memory on the HMI. So this is just a calculator to help you determine how much of memory you want. So I want to say I need to make that 1,224 to match what's there. If you had a word and you repeat it every 50 times, 918 bytes. Generally, we can actually make this as high as it can go. I think it's 2048, and then it'll be fine. Okay, apply. Okay, so it shows you here, we got a bit device, every second it'll log the start button. Flow alarm is literally what it says. It's a flow alarm that flows across the screen. It flows across the screen. Number of devices you want to monitor. So your e-stop, your trips, that sort of thing. But you can either, if you have it as continuous, let's say you structure your program correctly. So all your faults on a single address. So marker word 35. So remember, it's a bit only. So marker word 35.0, 35.1, 35.2. So VST1 chip, VST2 chip, VST3 chip. If you put all those consecutively, then that will actually, I'm just going to use one as an example here. This is then it'll automatically dump all the consecutive addresses in there. And from there, you can actually select your text alarm, your index. Say one for now. And basically, if start button had to come on, you'll get VST1 tripped. So go ahead and create a tag for VST1 tripped. Where to create a tag for that, then that will be linked to your flow alarm. And what happens is now, if that condition goes to on, you'll have an alarm that'll scroll at the, well, the choice is yours. I generally set it to above screen. So you'll have an alarm that scrolls at the top of the screen. And every time something else comes on, it adds, if another alarm comes on, it'll add to that and so on. So if you have a few systems that trip, as an example, it'll scroll at the top showing you that what's tripped. If your VST gets reset, it automatically clears from that list and it just displays what was on there. If there's no alarm, nothing scrolls at the screen on the screen. So you can once again you can set your flow speed, number of pixels you're gonna move, and your font size as well. Nice little feature for just quick view of your alarm. So you don't have to go into an alarm page. This will scroll on your screen and you can view. System alarms are built-in alarms that are in there. You can actually just put that into your screen if you want to. It's not often that we do. Then we got history alarms. History alarms are obviously important, so you can back up again to USB memory. So all this is purely based on how you structure it. This means it's actually difficult to go through all of this without an HMI and an actual program that goes with it. So you can actually, from your text table, you can add your text table in, and then I'll show you, when we go into the design, I'll show you where the alarm history actually gets loaded in and how it's actually linked to that. So we've also support recipe functions, and when previously HMIs never supported recipe functions, you have to do an entire recipe control via your PLC. Now you can do your entire recipe function via your HMI. So you can tell it a button to save, a button to load your recipe, what recipe, basic file, extended file, read write. It gives you, you can look at a bit to tell you that it's finished reading or writing. So you can go green, red, for example. Then recipe numbers, block numbers, and you can add multiple recipes into your system with multiple words. But that, when it comes to that, yeah, that's more on the more advanced side. Okay, so let's get back to our screen. I'm going to close all this now. So let's get back to our screen design, which is basically what we're here for now. So we have a bit switch, word switch, change screen switch, special switch, multi-switch, and we got our figures as well. And these purely are to draw a line, draw a circle, and add images and things as well. So let's start with a text block. Select text block, click anywhere. We can call this main menu or main screen. Say okay. Hold on for me 1 second, please. Give me 1 minute. Okay, thanks for the patience. Sorry about that. Okay, so create a main screen. Just a little text block, doesn't affect your program in any way, just visual. Double click on it. You can tell it, give it a different size, transparent text plate. Just say I want it to be dark green, white text. Say okay, and you can do that. So that's basically starting to design your screen, how you want it to look. Always up to you, colors up to you, text, fonts, all is up to you. We can add a clock in as well. So in your object window, you can click clock, click on there. For now, we just want to view the time, and I don't want seconds, say okay. Display, I want it to be transparent, so it doesn't look blue like that. Text, we can leave it at 14, say okay, and you can drag it to that point. So when you download to HMI, then you got this is what you're going to see initially. Okay, so you can draw lines, click on a line, draw a line. It's all design completely up to your preferences. circles, rectangles, round rectangles. Images I'll come back to because I want to show you guys how to add logos and external images into the system. Okay, so bit switch is, as it says, a bit switch. You can click on it and it gives you your action type. So you want on, you want off, momentary. If you press on, you press it once, it's going to stay on. If it's selected to off, you press it, it'll go off. Momentary is a pulse. You press it and hold it, it's on. You let go, it's off. Alternative, you press it, it comes on. Press it again, it goes off. Okay. Very important, if you're using alternative, it's important to use a lamp condition to show that the lamp must change state when you use alternative. So if you press it, it'll go on and it must show the lamp condition on its state. So I'm just going to go back to my PLC program. We created a little HMI start, HMI stop. So I'm just going to go back into tag. And I'm going to say HMI non-default. Let's just call it HMI control. HMI start, and we call it marker 10.0. HMI stop 10.1. So these are the same addresses that we've added that were on the PLC side when we did the HMI control. Are you seeing my XG5000 program open?
No, I can't see it.
Okay, let's just share that quickly. Okay, so you can see here that I've got, okay, I got marker with 10.0, marker with 10.1. So those are the two addresses I've just added into the XP Builder program. So I'm going to go back to XP Builder now. Okay, so there it is here. So we've got a bit switch. It's here. I'm going to double click on that again. Let's just go to there. Select HMI control. There's the start. Okay, so I'm going to put that as momentary. I'm not going to add a lamp condition, which is fine because it's just going to go off anyway because it's a momentary connection. Then we say display, and you can go into your library, and this is where you have a choice of buttons. So you have there, if you can filter it by color, let's just say I want my start to be green. Then I can even say it doesn't have to, you don't have to even select lamp, you can select switch, and you have a selection of switches, vectors or rasters, or you want on conditions, you want off conditions, what it looks like, square, rectangles, round, etc. It's all up to you. So I'm just going to go back to lamp to make it easier. I'm going to select that. I'm going to give it text as well. Say use caption and just say start. On off copy. So basically what it does is it copies the same thing to the on state and the off state. So I'm going to say okay. So now this just shows you that I've created a start button and it's linked to marker word 10.0. You have a little button up here as well that gives you, if you click on it, it shows you what happens when it goes on and off. Okay, so what we're going to do as well, let's switch again. Oh, let's make things easier because we're going to keep the same sort of button. I'm going to say Control C, Control V. Then you can put it next to the other one. And as you can see, it pins, it shows you where the center is, which is nice. Makes things a bit easier to line things up. So if we double click on that, then I want to change this to HMI stop, go to my tag. But this time I want it to be red. Okay, and I'll change my text to stop. Once again, on off copy. Okay, so what will happen now is if I press start, it'll start the system. Press stop, it'll stop the system. Okay, so now also we want to view the status of that output. So once again, and let's just say motor status there, and we had that.
Sorry,
yeah.
Just that last one. Sorry about that. If you want to make the on button, just change colors and use the exact same button to stop it again. Is that possible?
Yes, you can, but just that your PLC program will be slightly different now.
You'll use a
Because
different.
then you won't have a latching circuit. You'll just have a single input contact to an output.
Okay.
You press it once, it goes on. You press it the second time, it goes off.
Okay. All right. Thank you.
We'll draw something up like that just now. So we will link that output there. So we've got a bit lamp. I'm just going to put a bit lamp in there. So the bit lamp is basically just going to read from the status of a device. So I'm going to go on there, HMI control, Q 0.3.0 says that's terrible. It's very US. Okay, then once again you can go display there. So you got then you can see what it's going to look like. So on it's going to be an on red, off it's going to be dark red. So what I like to do is I'm going to say on image, I want it to be green. So select that. Off image, I want it to be red like that. Say okay. So that's the status there. So once again, we can look at what it's going to look like. Say object on off, and that is give you the state of that. So now as a quick demonstration, let's just show you how this is going to work. So I'm going to see if we can share. Okay, let's go back here. And let's just start the simulation. You have to start the XG5000 simulation first before you start the XP Builder simulation. Okay, so that's running. We're going to go back to XP Builder. Okay, give me a sec. So XP Builder simulation is this little start button here. Click play. Okay, let's close that. Play again. There you go. Okay, so this is a little simulator. Shows you that what we've created already. I'm just going to share that again. Okay, so I don't think I'll be able to share both the simulation and so what I'm going to do now is if you just view what's on the PLC screen, XG5000, if I click start on the HMI simulator, see I'm holding the start button down on the simulator, and then the HMI start comes on. And press stop, it'll unlatch. And then what I'll do is I'm going to share the screen back. I'm going to show the simulator screen back on now. And then what you can see now is the green here showing that motor 3 is running. I'm going to press stop and it goes red. So press start, it runs again, and stop, it goes red. So this is actually linked by simulation to the XG5000 simulator as well. So we can close that. I'm going to share the XP Builder again. Excuse me for 1 second, guys. I want to get some water. Okay, thanks guys, sorry about that. Okay, so basically, that's our little start-stop circuit and review the status. Now we also had our VST1 speed that we created on 101. Let's add that in now as well. So that's to change the speed of the VST. That we can do simply by a numeric input. Click on there, click there. Go back into our tags, settings, VST1 speed. Now this is where you tell it, okay, it's a 16-bit value, we know that. We can leave it as an unsigned decimal and your number of display value. So you can actually, we know up to 50 Hertz, it's 4 digits and 2 decimal places. So what that does is we got up to 50 Hertz and we know that 5,000 is 50 Hertz. So as a display, if you say 50.00, it'll be 50 Hertz, which in the PLC side will equate to 5,000. So I say 4, 2 decimal places, say okay. And as well as you got your display text, let's set it to center. Say okay. You can give it text here as well. You can say VST1 speed reference. Put it on there, and you can even give it and just say Hertz. Sure, Hertz. There's another way of doing this as well. Let's just move this out the way. I'll show you a little easier way. You can go to format. See, immediately it grays out the decimal digits. But to create the decimal digits, you can press star star dot star star, and you can say Hertz in that format. So you can tell it what format you want to use, and it puts it in there. So it gives you your unit in the display as well. So when you download to HMI and you have to tap on that, it'll give you a keypad, you enter your value, and it'll write to your PLC. So if I double click on that again, so you can see use input function, which is what's nice is they've, for example, you've created this in there. Now I realize, okay, I don't want it to be an input function. You can click on that. It'll purely be a numeric display only. See, as you can see, this changes as well. But right now, we're going to leave it as a numeric display, numeric input. Say, okay. So I'm going to start the simulator again. Starting the XG5000 simulator first. Okay. I'm going to go back into XP Builder. Start XP Builder. And you can see here, so 0.0 Hertz. If I tap on that, the keypad will pop up. I want to go to 25 Hertz. I say 25.00, enter, and it gives me 25 Hertz. Now I'm going to go into my XG5000 and share the screen again. And as you can see, value is 25 Hertz in there. So if I had to change that again, I'll change it to 30 Hertz, enter, and the value changes in there. So that's a simulation link between your XG5000 and your XP Builder software. So I'm going to close that. Okay, so now we've got multiple screens that we've added. We've got two other screens. We want to change screen. It's a simple little button called the change screen switch. You click on there, tell it which screen you want to go to. I want to go to screen 2 with that button. A display, you can say library. Make it a blue button. Hold on, I just want to say off, so I can go library. One image I want it to be the same. Okay, text settings, on off copy. Okay. So what that does, as it says, is a change screenshot. So when you press that button, it'll go to screen 2. And if you go to screen 2, go to settings. So I'm going to just copy this from here. I'm going to go to screen 2, put it on there. But this time I'm just going to change it. I want to go back to screen 1. Text. I'm just going to say main. On off copy. And that takes you to a main screen. So that's very, very simple. Then what's nice as well is we got something called multi-switch. So if you use a multi-switch, what a multi-switch does is it gives you one button can do multiple operations. So you can do a boot operation, you can make it go on, switch a device on and off. You can do a word operation where you can actually write a value into a word as well. You can change the screen with the same button. So you can press a button, change the screen as well as switch something on. There are times we are going to use that, and there are other times where you are obviously not going to use it. So if you need to use multiple functions at the same time, you can use a multi-switch. If you're not happy with something that's there, you can tap on it and click delete. The HMI also supports pie graphs, meter graphs, so you can add the bar graph in. Click on there, select the device that you want to use. So if you've got your analog value, your temperature, you can use that address as your temperature. Then you can say a range of up to 300, from 0 to 300, and the bar will fill up. You can design your bar as you want with different colors, transparent background images. All that's up to you as you design. You can change the background of your screen. If you right click on your screen, go to screen property, and select background. You can use a background color, you can use a background image that you need. It's up to you how you want your HMI to look. And also the history alarm viewer that I was speaking about earlier. So history alarm viewer, if you click on there, so this is what, so you want number of rows, what state, which alarm group you want to look at. So we're going to look at all the groups, for example. You want to display the restore filter, the check filters, or display only checked. And you want occurrence, message, group, restoration. So this tells you what you want to view in your history group. So if you click OK, this will display as you go through. Now, obviously, this is going to keep filling up and you don't know what's happening. It's every time there's a change, it's going to change. So to view and to scroll, through your device. Excuse me. So the view and to scroll to your device, what we have are special switches. So if you click on special switch, click on here, this gives you the internal buttons that the HMI supports. So we are looking at the history alarm viewer now. So we can click on there. We can say we can want to go history alarm viewer line up and click on that. And that automatically registers that button to scroll to line up. Say display, you can change the display to an up. So every time you press up, it'll scroll up. You can copy and paste that. Then we can say line down, display. And so on and so forth. So your special switches is what controls your built-in, your logging trends, your trend graphs, your alarm navigators, your alarm viewers, your data lists, your logging viewers, that sort of thing. So your special switches is what controls what's internal to the HMI. Okay. So now we've done that, but we've also want to make it look a lot better. So we have our built-in graphic library, but you want to add more things into your library. That's stuff that the HMI doesn't have. Basically better looking images, your company logo, and that sort of thing. So the easiest way to do that is to click Add. Let's just call that logo. Say okay. So what it does is tells you logo is added, and you got a logo tab now, and you want to add another image into it. So if you had to right click on there, and you open in the white blank spot, say insert image, and then you can go into wherever you've downloaded images. For example, I'll just go into the pictures, save pictures, there's nothing in there. Let's go photo galleries and say open, and it adds that in there. So if you want to add that image in, you can click on image, click user now, select that, and it's going to add the image in. So you can add your company logo, you can add all that in, and then you're good to go. Very simple. So you can add multiple images. If you can add another image, right click, say insert image, and you can go into your pictures. Any questions so far?
Yeah, can you make that picture like a watermark?
No, you're gonna have to, no, you can't.
So it's behind your text and all that stuff.
Yeah, you have to create an image that looks like a watermark, and then you can click it and send it to back. So it stays behind everything else. But it'll read the raw image as it is. So
okay, but you can right click on that image and say send to back.
Send to back, you can, yes.
So that's fine. It doesn't have to be watermark. That's, I mean, the other stuff can come in front of it.
Oh yes, you can. Yeah, you can send. Yeah, you can send that to back, or you can bring just particular devices to the front. Yeah. Okay. And then finally is downloading and uploading from the HMI. So downloading is done simply by clicking that. If you have a USB, it shows you here. Click on settings. You can select USB, Ethernet, or 232. Generally, it's going to be every one of our HMI supports Ethernet and USB. So, well, okay, the EXP20 doesn't have USB, it's got Ethernet built in. So you click on USB, for example, say OK, and download, and this will download. So you have the option as well of include upload project file. Always click that tick unless you don't want anybody to be able to upload the program from the HMI. But generally, we like to keep that ticked because if you lose your program or your laptop gets stolen or server crashes or whatever it is, then you can go back to site and say upload the program. So that is there. You can say upload project file, ticked, say download, and it'll download to the HMI. Then you can say upload as well. If you want to get the data from the HMI, say upload, it'll pull the HMI project into your laptop, and this is where you want to save it to. Okay, any questions? Just that the HMI is quite, it can get quite in depth, so it's actually quite a bit to go through, especially when it comes to the alarm history. So I tell guys, when we come to, if you're doing a project and you require that, then I will help you guys personally, privately, and we can sort that out for you guys. So based on what your project requires, then I can assist with that. Because going through explaining every little detail in an HMI will take forever. So as you guys design HMIs and say, okay, I want to use this function, how do I do that? Then I will assist in that sense. Because then we'll have stuff to work with, we'll have addresses to work with, we'll have information to work with, and we can do that. Any questions?
Latest versions 4.51 and 3.2.
Correct. Yes. Those are the latest versions. Yeah. All right, guys, happy? If you have any questions about HE 5000 as well, let me know.
Can older HMI support new software?
The older XP screens do not support, are not supported on version 3.2. If you need to use the older XP screens, then you need to use version 2. Between version 2 and version 3. I think version 2.2 will support the older XP screens, but all EXP and IXPs will be supported on the newer versions.
Can you have multiple versions applications on the same laptop?
Yes, you can. Yeah, not with XG 5000. XG 5000 doesn't like that, but XP Builder is fine with that. So you can have version 2.2 and version 3.2 installed.
That was going to be my question, because I think we've got older HMRs all over the country.
Yeah, so you can. I've actually got that as well, because obviously you don't want to say, oh, sorry, I can't support you because yeah, I don't have the version of software, but I do have 2.2 and 3.2 installed. But with the XG 5000, it's fine. It's backward compatible all the way to the older ones. Anything else?
That's it from our side. I don't know if anyone else has got any questions or anything.
Thank you very much for attending. I hope it was informative.
Yes, very applicable, very hands-on.
Yeah, thanks, Devin. Appreciate it a lot.
Yeah.
No
Thanks,
problem. If you
Devin.
guys have any questions, give me a call, give Bryce a call, and we'll help you guys out.
Yeah, you guys can, thanks for everyone for attending. If you do have any questions, you can obviously get hold of Devin directly or through your corresponding sales rep in your area. And as I said, I will be uploading this training session to YouTube later if you guys want to recap or if you missed some sections you had to leave earlier. So those links will be sent out to each and every one of you. Thank you very much.
Thanks. Thanks for uploading this training. Would be great.
Thank you very much.
Yeah, thanks, guys.
Thanks,
a lot.
Thanks, guys.
Cheers.
Cheers.
Thanks.
Pleasure.